Hello guys, welcome back to our channel. So today we are starting with another chapter, that is application of derivative. Till now we have completed differentiation. So please subscribe our channel, hit the bell icon and do comment, and please share it with all your friends. So now let us begin with application of derivatives chapter. So in this chapter, firstly we are starting with derivative of an equation of a curve gives slope of tangent at any point x1 comma y1. It means dy by dx point point x1 comma y1 is equivalent to m, which is slope over here, slope of tangent, slope of tangent. Now equation of a tangent, let us know y minus y1 equals to m into x minus x1. M is equals to dy by dx at point x1 comma y1, which is a point over here. Equation of a normal, let us know about it. Slope is m is equals to dy by dx at point a. Y minus y1 equals to negative of 1 by m, x minus x1 over here. Now rate of measure, s is displacement, v is equals to ds by dt, which is velocity, a is equals to dv by dt, which is acceleration. when when object stops at rest, reverse take velocity v is equivalent to 0 every time. If these three cases are there, take velocity is equivalent to 0. Rate of change. Surface area of a sphere. Area is equals to 4 pi r square. So now dA by dt with respect to time, 4 into pi into 2r into dr by dt. So dA by dt is equivalent to 8 pi r dr by dt over here. If we have volume of a sphere v, v is equals to 4/3 pi r cube dv by dt with respect to time. Every time we differentiate, so 4 by 3 constant, pi also constant, so here it will be cube is there na, 4/3 pi r cube. So here 3 r square into dr by dt. So here 3 gets cancelled. So we get 4 pi r square dr by dt as volume of a sphere derivative. Now here we have surface area of a cube. Surface area is equals to 6l square of a cube. So dA by dt is 6 into 2l into dl by dt. So here 2 6 are 12, L into dl by dt. Side by side differentiation is also happening, that you can revise it. Volume is L cube. So dV with respect to T, here 3L square. Here we have dl by dt. Now surface area of a cylinder RCC. It is surface curved surface area is equals to area is equals to 2 pi r h. Differentiating dA by dt is equals to 2 pi r dh by dt over here. This is over here. Volume is equals to pi r square h. R is constant over here. So dv by dt is pi r square dh by dt over here. Now total surface area is equals to 2 pi r plus h over here. So now solving, area is equals to 2 pi r square plus 2 pi r h. We multiplied this. Now dA by dt, differentiating with respect to time. So 0 over here we get plus 2 pi r dH by dt over here. So here dA by dt is equals to 2 pi r dot dH by dt. For more basic formula, if you don't know this basic formulas also, go to basic geometry and you can learn it over there also. Now let us begin with approximation, which we have over here. So in approximation we have x is equals to a plus h. So f of x is equals to f of a plus h over here. So f of x dot dot f of a plus h times of f dash of a over here. Take derivative, take derivative of f of x to f dash of x. Find f a and f dash of a also over there. You can get it. Let us take examples for better understanding. Example, root of 8.95. Here f of x is equals to root of x we take. F of a is equals to root of 9, and so it means that is equivalent to root of 9 plus minus 0.05. Here a is equivalent to 9 and h is equals to negative of 0.05 over here. So here we have put up this, and f of a is equivalent to 3. So f dash of x is equals to 1 by 2 root x. F dash of a is equals to 1 by 2 root 9, which is 1 by 6 over here. This way you can solve. And now after this you can use this formula and get your answer over here. Now Rolle's theorem. If if fx is continuous on a and b, fx differentiable on a comma b, then f of a is equivalent to f of b. This is condition. Then there exists at least one c in a comma b such that f dash of c is equivalent to 0. Lagrange's mean value theorem, which is LMVT. If function is continuous on a comma b and function is differentiable on a comma b over here, there exists at least one c. There exists at least one c. So f dash of c is equals to f of b minus f of a divided by b minus a over here. Now increasing function and decreasing function, what does it mean? Increasing function over here, f dash of x is greater than or equal to 0, and decreasing is f dash of x is less than or equal to 0. Monotically, strictly increasing function means f dash of x is greater than 0, and monotically strictly decreasing function means f dash of x is less than 0 over here. So before maximum value, one thing I want to tell you is f dash of x is equivalent to 0, then m is equivalent to 0. Therefore tangent is parallel to x axis. So we can't say fx is increasing or decreasing at that point. We can't say fx is increasing or decreasing at that time over here. Now maximum and minimum value, let us know. Here we need to do is the second derivative test. So let us do the second derivative test and let to know. Second derivative test over here. Maximum and minimum value says second derivative test. So here f of x we here f dash of x is equivalent to 0 for maxima, for max and minima, for maxima and minima over here, and for second f double dash of x here, and here we get positive and negative. So here it is positive, then it is minima, and if it is negative, it is maxima over here. The value of x is said to be maximum or minimum. The value of f of x is said to be maximum and minimum values. Let us know about the shortcuts over here also. It will be very much easy for us to understand. So now let us know the shortcuts. Tangent. First, tangent is parallel to x-axis over here. It is m is equals to 0, dy by dx is equivalent to 0. Tangent is parallel to y-axis. Here tangent is parallel but to y-axis. So slope is equivalent to infinity, dy by dx is equivalent to infinity over here. Tangent makes an equal angle. Tangent makes equal angle over here with axis, equal angle with axis. So here the slope is m is equals to plus minus 1 over here. Here if we have x plus y is equals to a, then x into y is maximum when x is equals to y is equals to a by 2 over here. Now from rectangles of given perimeter, from rectangle rectangle of given perimeter perimeter, the the square has the largest area over here, the largest area. From rectangle of a given perimeter, from rectangle of given perimeter, the square has the largest area. From rectangle of given area, from rectangle of given area, the square has the largest square has the least, sorry, it has the least perimeter. The greatest triangle inscribed in a given circle is the greatest triangle inscribed in a circle that is equilateral triangle over here. Now the height of a cylinder, the height of the height of cylinder of max volume inscribed in a sphere of radius r is 2r by root 3 over here, and the height of cone of maximum volume inscribed inside a sphere of radius r, or everything question is same. Then height of, here it is cone and here it is cylinder, difference is then it will be 4r divided by 3. So I hope I have cleared this chapter. I hope you have understood this chapter. Thank you for watching this video. Please subscribe our channel, hit the bell icon and do comment. Thank you.